topic in section 3 is rational zeros theorem. That gives us the possible zeros of a polynomial, or the possible solutions. It's a method to determine the possible solutions or possible x-intercepts of a given polynomial. And it's p over q. It's p divided by q, where p are the factors of the constant term, right? That's the one without the variable, and then divided by q, and q is the factors of the lead coefficient. And on all these, they're all going to be plus or minus factors of the lead coefficient. So these will all be plus or minus lead coefficient. Lead coefficient. Okay, so that is called the rational zeros theorem. It's the possible, remember, it's just the possible rational solutions, or rational zeros. Okay, so here we have a polynomial and we're trying to find all possible rational solutions. Okay, so here's our constant and here's our lead coefficient. So I need to list all the factors of 6. So factors of 6 and factors of 2. Okay, so factors of 6 is 1 times 6 and 2 times 3, but then they're all plus or minus, right? Because I could do a -1 and a -6. That'd be a +6, right? So you're going to get plus and minus in all these. 2 is 1 and 2, and then they're all plus and minus. What I do usually is I just wait till the very end to put all my pluses and minuses in there. So I'm going to take every single one of these, okay, all 4 of those, and divide it by all 8 of these. Okay, so it's a whole list. I got to take one of the factors of my constant and divide that by 1. I got to take this 1 again. So there's my first one. My second one, 1 divided by 2 now. 1 divided by 3. And 1 divided by 6. Okay, and then they would all be plus or minus. Now I got to take, again, now I got to take 2. So now I move on to the next factor, which is 2. And I got to divide it by all 4 of these. So that continues my list, right? So then I would have 2 divided by 1. I would have 2 divided by 2. I would have 3 divided by 2. And I would have 6 divided by 2. Okay, so now I can simplify these and then just cross out and just, I only need to write it once, right? So 1 over 1 is the same as 2 over 2. So that's 1. So I don't need to list it more than once. I have 1/2. I have 1/3. So you could go through and mark them out as you go, I guess. 1/3, 1/2, 1/6. 2 over 1 is 2. 2 over 2 we already wrote is 1, and then 3/2. And then 6 over 2 is 3. So there is the list, and then they're all plus or minus. So notice how I just wait till the very end to do plus or minus. But don't forget that, especially when you're finding later on, actually finding the solutions. This is just possibles. But when you're finding the actual solutions, you make sure they're both plus and minus. You got to check all the plus and the minus ones. Okay, so that's A. Now we want to find all rational solutions. So now we're going to find the rational solutions. Okay, so let's go ahead and find all rational zeros, right? So now these are my possibilities. Now I'm going to find the actual ones, where here I need to use synthetic division. Okay, so I list my coefficients 4, 7, -12, -3, and 2, right? Nothing's missing here. 0 here. Now what's going to go in the box is going to just start my list. So I'm going to start with +1, and I'm going to run it through. If I don't get 0 at the end, then I need to go to -1. This would take a long time if I went through all of them, right? But if you kind of think about it a little bit, you might be able to reason through eliminating some of these. Okay. So because we need eventually at the end we need a -2 here, right? So you can kind of think about running it through kind of in your mind a little bit and which one would be best. So we're going to start with 1 though. So 6 plus 0 is 6. 6 is 13. Is 13 is a positive 1 is positive 1 is -2. We do get -2, which then does that turn that into 0. So that means x equals 1 is a 0, right? So x equal 1 is a 0, meaning x minus 1 is a factor. Now what we can do, a few different things. We could start over, so we have 1. Now I could run it through again and check it, but I do have one of them, so I'm just going to put that over here. What you can do is you can just use this new polynomial right here. You can use this one and just do synthetic, just start over again with synthetic using these, this polynomial. So I can just keep going, put a 0 here. Now I need to make sure I need to start out at 1 again. I don't have to start at 1 again, but 1 is also a possibility, right? There is a possibility of having 2 zeros that are the same. So if you run through, you get an answer, and then you start doing it again, and you don't get anything as an answer, well, you need to go back and check that first one that worked. So 6 is 19, 19 is 20, and 20, so this one doesn't work, so then I have to erase that. And then pick another one. I can pick -1 and see if -1 works. And then I would just keep on going. But you notice that we had a to the 4th, and now we're to the 3rd. So if I do it just one more time, if I find one more, then I could do quadratic formula, or I could try to factor to find my other zeros. But I do need a +2 here, so I'm probably going to have a negative somewhere because I need to get this smaller. Like I have that 13, so I need to kind of get it smaller. So we could try -1, so 6, -6. Right, so then that kind of drops down to 7, -7, -6. No, that's not going to give me 2, so I can't do that. So really this 6 in front I don't have to erase, right, because there is a 0 here, and it's always going to be 0. Okay, so if we try 2, 2 is also not going to work, but -2 does work. So that would be -12 is 1, that's -2, that's -1, and then we get a +2, so we get a 0. So that's a second 0. Is x equals -2. Oops, x equals -2. Now we could keep on going if you wanted to, or now we have a quadratic, right? Because we divided it once and then we divided it twice. So we do have a quadratic. So we could go ahead and use CAB or quadratic formula and factor. So we're asking ourselves what times what is -6, but subtracts to 1. So that'd be again 2 and 3, right? So 3 and 2, and then 3 minus 2. So then we have x plus 3, x minus 2. Then we can divide by our a, which is 6. We can reduce those fractions. And so, well, actually, really, since we're finding zeros, we can leave these fractions as they are, or you can reduce them, it doesn't matter. But we're trying to figure out what makes these 0, right? What gives us a 0? So we're trying to figure out what makes x plus 3/6 0. Wouldn't that just be the opposite? Wouldn't that be -3/6, which is -1/2? So that would be a 0, because we're trying to find zeros, right? So if this is a factor, that means it would be, we can set it equals 0 and solve for x. So we just subtract 3/6 on both sides. Same thing with this. We could add 2/6 to both sides. So x equals 2/6. Or 1/3. So those are our 4, -2, and the top one was 1. So those are our 4 actual rational zeros. Okay, so what that means is if you plug -1/2 into this, into synthetic division, they would have a remainder of 0. Same thing with 1/3 if you would have plugged 1/3. Fractions are very difficult to plug in sometimes, but they're doable. Okay, so here is your homework, page 315, number 35, dealing with this type, using that the possible rational solutions. Remember, they are only possible. They're not the actual ones. You have to run them through and check and see if they actually get a remainder of 0. Okay, so I'm going to do 35 for you. Okay, so here's 35, right? Here's the polynomial. We'll ask to find the possible rational solutions. They're rational, right? So there might be some imaginary solutions possibly in here too. We'll discuss that in the different and more topics later on. Then we're asked to find all the rational zeros, and then we want to factor that. I don't know if I did that, and I didn't do that really in the example, but that's okay. I'll do it here. Okay, so we take our p, which is -10. We list the factors of -10. That's 1 and 10. That's 2 and 5, and that's it. And they're all plus and minus, right? So don't forget, they are all plus and minus. Now we're going to take each one of those and divide it by each factor of the lead coefficient, which is 1, and the factors of that is just plus or minus 1, right? So I'm going to take each one of these and divide it by 1. So they're all the same, right? So A would just be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. When you actually have a different number as a lead coefficient other than 1, it's going to be a lot bigger. Okay, you're going to have a longer list here. All right, so then we can actually do synthetic division for b. So we list our coefficients: 1, -2, -13, -10, and degree is 3, so we should have 4 coefficients there, which we do. Plug 0 into the second. Plug 0 in. We're going to run this through. We can start with 1, right? Because I do need a positive 10 here, right, to get 0. So you can kind of start working backwards a little bit to think about what number should I actually put in. But most people start low. They start at 1. So we get 1, so we get -1. We get -1, so we get -14. And that's not going to be positive 10, right? So we can erase that. So we can't do 1. So we probably need some bigger number bigger than 1. So we can go to 2. So we get 2, we get 0, we get 0, we get -13. Okay, that's not going to work. How about -1? Okay, so we'll try -1, which I think is going to work here, because it's going to start dropping these down a little bit from -13 going down to -10. So -1 times 1 is -1. That's -3. That's a positive 3. That gets us to a -10, and -10 times a -1 is a positive 10. So we get 0 as a remainder. So that means that x equals -1 is a 0, and that means x plus 1 would be a factor. So that kind of goes with my C part is factoring it. So there's one factor I got listed. Now I can continue on, right? But we do go from a degree 3 to now it's a degree 2. So if you wanted to, you could factor this. What are the factors of -10, or factors of 10 that subtract to 3, which would be 5 and 2. So you could continue on. You could start right here and go and put something in the box here. Just restart your list of possibles and find out what you can get to 0. Or we know this is a quadratic, so we know it is we can possibly factor it, right? So factors of your CA, which would be -10, adds up to your B, which is -3. So what times what is 10? 5 and 2, but then subtracts to 3, 5 and 2. So x plus 5 here, we can divide by our A, which is 1, so that's not going to change anything. And then x minus 2. So those are 2 factors. We had our original factor, which is x plus 1. So here are the factors. So that's part C, already done for us. So we got our factors. Then part B was asking for the rational zeros, which would be x equals -1, x equals opposite of this 5, which is -5, opposite of -2, which is 2, because these make 0, right? 2 minus 2 would be 0. 0 times anything with 0. 0 times anything is 0. That's what we get an answer of 0 when we plug those numbers in. So there is number 35 for you.